Hello and welcome back to today's video. Today we're going to be looking at solving systems of equations. So in our prior video, we were looking at solving systems of inequalities. We were graphing two lines, then doing a dotted or solid line, and then shading. In today's video, we're not going to be working with inequalities, but rather just equations to be solved. So we'll be using the equal sign, and we're going to be graphing some lines. Now, this is going to be a three-part series because there are three different ways we can solve systems of equations. There's a couple more, but we're actually only going to look at three of them. For this video specifically, the first method we're going to look at in solving equations, or solving systems of equations, is we're going to use the graphing method. And we're going to do it in two ways. First, we're going to do it by hand. We're going to look at some equations, and we're going to figure out how they can get graphed. So, equation like such, we're going to tackle them, how they can get graphed, how to graph them, how to find the solution. And to follow up, we're going to look how can we use our calculator to solve the same problems or similar problems because, well, when it comes to some testing, SAT, ACT, you're allowed to use this guy. So let's make sure we can use this as the tool that it is. So let's start to get the basics down. If we're trying to find a solution to the equation, really we're looking for a point that is on both of these lines or satisfies both of these equations. So to do this first problem, what I'm going to do is I'm going to just graph these two lines. I'm going to start with the y-intercept. This first equation, I'm going to start with that 1. And I'm going to use the slope. Then that first equation, it's a 1. And I'm going to plot my first line. Looks something like that. It's a line, so we have the little arrows at the end. First line, graphed. Second line, same deal. I'm going to start at that y-intercept 4. Start at 4. And my slope is down 1 over 1, slope of negative 1. If we can get this graphed. So, for our first problem, what we're looking at specifically is the intersection. So where is the solution? That solution is where do these two lines intersect. So in a problem like this, do these two lines intersect each other? They do. Where they intersect is going to be the solution. Now, before we jump into actually solving them, we're just going to note how many times do they intersect. So here, these two lines intersect at one spot. In this problem, that point looks to be about 1.5, 2.5. Now, we'll be a little more precise in the coming problems, but just so you get the idea of, we're looking for that intersection. Where do these two lines cross? Again, let's graph this line, see where they happen to cross. First line looks a little backwards, so I'm just going to rewrite it like this. Y-intercept 5, slope of 2. Plot that line. Second equation, I plot that second equation. When I do that second equation, something interesting happens. Do those two lines intersect each other? No. These two lines do not intersect. Do not intersect. And if you're looking at it, maybe you can see why they do not intersect. So there is this problem. There's no solution. And maybe you could have determined that before you graphed that. The way you would have seen that is both of these equations have the same exact slope. These two lines are parallel. So parallel lines won't have any intersections. Therefore, there could be no solutions. So our first example, the two lines intersected each other. Our second equation, our two lines, well, they didn't intersect. They run next to each other. So there is no solution. Let's look at our third example. If I graph that first line, 1, slope of 2, I graph it, looks something like that. Now if I do that second equation, I want to get that y by itself. So I divide everything by 2. And just sort of putting that x term first. We would notice it's the same exact equation. Because of the same equation, our solution, these are the same equations, there are an infinite number of solutions. So for our first video on this series of solving equations, what we're just looking at is how many solutions are possible. It's possible our two equations, they cross once. The two lines they cross, and so there's one equation, one solution. It's possible that the two lines never cross, so there's no solutions. Or it's possible that these two lines are in fact the same line, and so there's an infinite number of solutions. Now the easiest way to tell this one solution, infinite solutions, and no solutions is by graphing it, but there are also a few other ways using our other methods. So for today's video, just recognize the number of possible solutions. Moving forward, the next part of the series, the next video will be how to use graphing, and that's where this calculator is going to come in handy. How can we graph our equations to find the solution? Have a good day, be well, take care. If you have any questions, let me know.